So a body is thrown vertically upwards. The height h attained in time t is given by, I'm coming, Leonard, and then, sir, please, I don't understand the last question. Don't worry. Mhm. So a body is thrown vertically upwards. So this is vertically upwards motion. It's thrown vertically upwards. The height h attained in time t is given by h is equal to 20. H is equal to 20 t minus. Please mute yourself when you join. Okay. So the body is given by this. The height h attained in time t is given by this. Determine the maximum height reached by the body. Determine the maximum height reached by the body. So clearly, it's a vertically upwards motion where the body moves against the direction of gravity. Okay. We have to determine the maximum height. H max raised by the body. I'm coming. Let me mute all because I'm getting a weird feedback here. Willie, your microphone is on. So we have to determine the maximum height. So this is the vertical height reached by the body in any time t. But when a body is thrown vertically upwards, so this is the ground, and the body is thrown vertically upwards. Let me assume the body is at a height h from the ground. H from the ground. And the body is going vertically upwards. How would you determine this vertical height h by the body? How do we determine this vertical height h when the body is thrown vertically upwards? Yes. Somebody to help me. How do we determine h? Yes, Lizzie? In a situation like this, how do you determine the vertical h traveled by the body?
Please, h is equal to ut minus gt squared over 2.
Ut minus, okay, half gt squared.
Yes, please.
So this is the general formula for a body projected vertically upwards. When you compare it with what the height h attained by the body at any time t, okay, don't you see a similarity? Don't you see Yes. It means that you can compare the general equation which you have given us to what the question also gave us. Is that okay?
Yes, please.
So when you compare, I'm coming. I want to drop the attendance on the platform. Please give me some time. I'm coming. All right. Come in, please. Angel, you have joined. You are welcome.
Thank you.
All right. So when you compare the general formula to what the question gave us, you can deduce that U is equal to 20 meter per second. Then this part, half G is also equal to 49 on 10. So if U is equal to 20 meter per second and half G is equal to this, can't we find G? We can determine G to be equal to 49 on 10 times 2. So that acceleration due to gravity is equal to 9.8. 9.8 meter per second squared when we compare. Okay. We are told now to find, hello.
Please, if you are finding G in any question, the answer you are supposed to get, is it 9.8?
It can be an approximated, you see, it can be 9.8 or something close to 10. Okay.
Okay.
The value 10 is even approximated. It's the actual value is 9.84 something, but we often approximate it to 10 meter per second squared. Okay. So from the comparison we made, U is equal to 20. And then we've had J to be equal to 9.8 meter per second squared. So if the question now is asking you to find the maximum height, we know at the maximum height, H max, maximum height V is equal to 0, and H max will be equal to, or H will be equal to U squared over 2G. So if U is 20 and J is 9.8, then we shall have 20 squared divided by 2 times 9.8. And this must be equal to I think 20.48. Check for me. 20 meter. Class. Let me finish the Okay, so that is the value of H, the maximum height reached, as demanded by the question. Another way out is that you can also find the time taken to reach the maximum height. You can also find the time taken to reach the maximum height. T is equal to U over G. You've had U to be 20, J to be 9.8. And so T would be equal to 2 point something. Please check for me, 2 point what? 2 point. Hello. Hey.
Please
T is
2.04. Please 2.041.
okay. So once I have T value, I substitute T into the equation they gave me. What we were given is that the height H by the body with time is 20T minus 4.9 T squared. So we have 20 times T is 2.0, 0.041. Okay, minus 4.9 times 2.041 squared. And this must also be close to H value of 20 point something. 20.48 meter per second. Oh, sorry, meters. So this is the other way out. Are we okay?
Yes.
All right. Let's look at, you said the difficult questions were which ones?
The last one too.
The last one.
The vector one. Yes, the vector question.
Ah, okay. Now the vector question. Let me go back to what I posted. Good. Listen to the vector question. Oh, shit. So, two forces acting in opposite directions have a resultant of 10 Newton. So, two forces, assuming the forces are F1 and F2. We are told that when they act in opposite directions, they have a resultant of 10 Newton. So I'm going to draw, because drawing it would help you understand better. So I have two forces acting at a point. When they act in opposite direction, F1 and then F2, and when two forces act in opposite direction, the angle between them, don't forget, is 180 degrees. So when they act in opposite direction, we are told the resultant is 10 Newton. So if F2 is greater than F1, here the choice is yours. Then the resultant R would be equal to F2 minus F1. And in this case, Leonard, what's the
Sir,
problem?
please, somebody's account has been hacked.
I think Jacinta. I'll take care of when we finish, okay? I saw it earlier, but because I'm teaching, the reason for it I've been quiet. So it's a scam. So just be alert to something like that. So if F2 is greater than F1, we are told the resultant force is 10 Newton. So 10 is equal to F2 minus F1. And this is equation 1. Are you okay with equation 1?
Yes, please.
Then if
Sir, please, could you come again? Sir, please, could
so,
you come
if
again?
we are told that when the two forces act in opposite directions, the resultant is always 10 Newton. And we learned that when two forces are acting oppositely, the angle between them is 180. So if you have two forces acting in this manner, then the resultant is always subtracting the least force or vector from the larger vector. So R will be equal to F2 minus F1. So I'm assuming F2 is greater than F1. You can also choose assume that F1 is greater than F2 and it will still be F2 minus F1 minus F2. The choice is actually yours here. But I am choosing F2 to be greater than F1. And so R is equal to F2 minus F1. Therefore, the resultant being 10 would be equal to F2 minus F1, equation 1. Okay. Gabriel.
Sir, please can F1 be greater than F2?
Oh, yes. The choice is yours. F1, you can also assume that let F1 be greater than F2. And it will still be R will be equal to F1 minus F2. So this time the resultant will be 10 is equal to F1 minus F2. The choice is yours. Because the question never wasn't clear, okay, concerning the larger force. So the choice is ours to assume.
Thank you.
All right. Then it goes on to say that if they act the same forces, if they act at right angles to each other, this time the resultant is 50. So when the same forces act perpendicularly, maybe F1 is here, F2 is here, and they act in such a way that the angle between them is 90. Of course, when I have two forces acting in this manner, the resultant will act from the zero origin upwardly along the diagonal. So this will be the resultant. Because when I draw equal vectors, the equal vector of F1 will come here, would have the same magnitude direction as this one. So F1. Okay. So even if I draw for one, I have the triangle law of vector is obeyed. A vector from here, a vector from here, then the resultant will be here. And so I can apply the Pythagoras theorem. So I can say that the square of the resultant, R squared, would be equal to the square of F2. So F1 squared plus F2 squared. Okay, so I'm told when they act perpendicularly, their resultant is 50. Okay, so 50 squared would be equal to F1 squared plus F2 squared. And this will be the second equation for the second condition. We are given two different situations when the two forces are acting oppositely to one another and when they are acting perpendicularly to one another. So these are the two equations which must be solved simultaneously. Please, are you okay? Are we okay? All right. So the next thing to do is about solving the two equations simultaneously. I have 10 is equal to F2 minus F1 as equation 1, and 50 squared is equal to this. Now, in solving the simultaneous equation, I'm going to use the substitution method. From equation 1, I'm going to make F2 the subject. So let's make F2 the subject from equation 1. Yes, somebody to help me. Let's make F2 the subject from equation 1. Yes.
If F2 is equal to 10 minus F1.
Open your eyes. We have 10 is equal to F2 minus F1, and we are making F2 the subject. So come again. What will be F2? Anybody else? Go ahead.
Please F2 will be equal to 10 plus F1.
So this is minus. When it crosses, when you send it to the other side, it will be positive. So 10 plus F1 is the value of F2. Now let's substitute this. Let's call this maybe equation 3. Substitute equation 3 into equation 2. We are going to substitute equation 3 into equation 2. What is 50 squared? 2,500 is equal to F1 squared plus. Now, wherever we see F2, we are going to put 10 plus F1 into the equation. So we have 10 plus F1 squared. So we've done the substitution. We are putting equation 3 into equation 2. So we are substituting 10 plus F1 in place of F2 and then squaring it. Are we okay? Are we okay?
Yes.
All right.
Please come again.
Please come again.
We are just substituting equation 3, which is 10 plus F1 into equation 2, which is 50 squared is equal to F1 plus F2 all square. So wherever you see this F2, come and put 10 plus F1. But don't forget that this F2 is squared. So it will be 10 plus F1 squared. So that's what I've done here. That's what I've done here. The substitution. Is that clear?
Yes, please.
All right. So let's expand what we have here. 2,500 is equal to F1 squared plus. Somebody to help me expand what is within the bracket. Somebody to help me expand what is within the bracket. 10 plus F1.
Please, you get 100 plus.
So
you get 100 plus 20.
Go ahead. All
Please,
right.
you get
So
100 plus 20 F1
plus what? Plus F1 squared.
F1 squared.
Okay, so the
Yes,
trick is that
please.
square the first term. 10 squared is 100 plus square the second term. F1 squared will be F1 squared. Then when you finish, multiply 10 by F1. That will be 10 F1. Then your results, multiply that by 2. 10 F1 times 2. That will be 20 F1. So let's group like terms. Let's group like terms here. F1 squared plus another F1 squared. So we have 2 F1 squared plus 20 F1 plus 100. You know, this is quadratic equation. So equate everything to 0. And equating everything to 0, we will send the 2,500 to the other side of the equation, because the highest power must always be positive. So we can't let 2F1 squared cross, else it will be negative. It has to be made negative, positive. So the 2,500 rather will cross the equal to sign. So we have 2F1 squared plus 20 F1 plus 100 minus 2,500. Are we okay here?
Yes, please.
All right. Now this is equal to 0 because we send this to the other side. So in effect, what we have would be 0 is equal to 2f1 squared plus 20f1 minus 2,400. Okay, minus 2,400. But we can divide through by 2. You see, when you have such terms, you don't work with large values. You must open your eyes so that if you can reduce the coefficient down to the least term, you do so. Looking at it, 2 can go into all the coefficients here. So divide through by 2. Of course, it's an equation, so you need to divide both sides by 2. 0 divided by 2 is still 0. So 0 is equal to f1 squared plus 10 f1 minus 1,200. So we have a quadratic equation. Let's compare it with the general quadratic equation. Please here, maybe you don't want to see the 0 first, so equate it to 0 here at the other end. It's the same thing. So compare it to the general quadratic equation formula. A squared plus bx plus c is equal to 0. So by this, when you compare, you could deduce that A is equal to 1. Please, here, our x is f1. Our x is f1. So A is equal to 1. B is equal to 10. C is equal to negative 1,200. Then you come to use the almighty quadratic equation formula, which is x is equal to minus b plus or minus root of b squared minus 4ac. All right. All divided by 2a. So after getting this equation, we are only comparing it with the general quadratic equation formula to get the value of a, b, and c. Collect.
So please, I wanted to ask whether if you are presenting your solution in exams, it's important to to show whether A is like the digits A and B and C is equal to.
Yes, every stage, every step here is very, very important. That would inform the teacher how you manage to get F1. Okay.
Okay, thank you.
All right. So here we don't have X, but our X is F1. So it means that F1 is equal to our X is actually F1. So F1 will be equal to minus 10 because this is minus B plus or minus square root of B squared. Okay, so 10 squared minus 4 times A is 1. A, we wouldn't worry ourselves with because 1 will be the same thing. But C is negative 1,200. All divided by 2A. So 2. A is 1. So F1 is equal to minus 10 plus or minus. Now this is negative times negative positive. So we have, when you multiply, we have 4,800 plus 100, giving us 4,900. This one is giving us 4,800 positive plus 100, totaling 4,900 divided by 2. What is the square root of 4,900? Yes, that's 70.
70.
Good. So minus 10 plus or minus 70 over 2. Now, Paulette, look here. From what we have, it means F1 would be minus 10 plus 70 over 2, or minus 10 minus 70 over 2. If you look at this, this will give you negative, and we don't have anything like negative force. So we ignore the negative and then only look at the positive. It doesn't mean that you ignore the negative right from here. Sometimes the negative, when you consider the negative of the plus or minus, the negative will not give you a negative result. If it doesn't give you a negative result, then it means you have two positive values for whatever variable you are looking for. You don't throw the negative away if it will not give you a negative result. Paulette, are you okay?
Yes, please.
And I'm referring to the exercise I gave you. Some of you did that. I'm throwing this away, not considering it, because this will give me a negative F1. Okay, but if when I had considered minus, it is a positive, then meaning I'll get two positive values of F1. Here I must consider everything. I cannot ignore any. All right, so this is thrown away because it's a negative force. F1 therefore would be equal to 70 minus 10, which is 60 divided by 2. So straight away I have 30 Newton for F1. Now, having had F1, come and use any of the equation. Please, I'm coming. Let me pick a call from school and get back to you.
Yes, please.
Okay. So once I have F1, you can use any of the equations, whether equation 1 or equation 2, to find the other one. But the easiest one certainly will not be the quadratic equation. Use the linear equation. Use the linear equation. 10 is equal to F2 minus F1. That will be easier. So F2 would be equal to 10 plus F1. 10 plus F1, which is 10 plus 30, giving F2 40 Newton as the answer. So the two forces, therefore the two forces would be 30 Newton and 40 Newton respectively. Please, is that okay? So it's quite of a lengthy vectors question I give, but I think it's worth solving it. All right.
Yes, please.
The other objective questions I think I'll solve them and then send to you so we can continue with our vectors today. All right.
Okay.
Can I redirect the screen? Or you are still writing? In fact, you are done. Silence means yes.
Okay, I'm not done.
You are not done, vain. All right, so let's continue with our vectors.
Please, I'm done.
All right. Oh, but some of you solved it and then got it. Yes, meaning some of you are working so hard. So please, I entreat each one of you to also work so hard. Okay. Work hard for me. All right, so last time, Angel, are you there?
Yes, please.
Last time we looked at vectors relating to one another, two vectors. In fact, we narrowed it to two vectors. To when the angle between them is acute, meaning the angle is less than 90. Any angle greater than 0 but less than 90. And then saw that, okay, when two vector quantities are related in this manner, we got the resultant R. We got R squared to be equal to F1 squared plus F2 squared plus 2F1 F2 cos theta, or R squared is equal to F1 F2 squared minus 2F1 F2 cos of 180 minus theta. They are the same, either the plus or minus. Now let's look at when the angle between the vectors, two forces, is acute. So when the two vectors F1, F2, and the angle between them is obtuse, when theta is obtuse. Angel, what is an obtuse angle? Eva, are you there, Eva? Okay, Angel, what is an obtuse angle?
It's an angle greater than 180.
Greater than 90.
90. Hey, wait.
But less than
180.
180. Okay, so this is how this angle is. All right, now looking at the directions of the forces is in this array. You can't tell where they are going. F2 is in this direction. F1 is in this direction. You ask yourself, so where are they going? So the two directions do not make any sense. So you have to realign their directions so that they follow a sense of order. And that is using equal vectors. using equal vectors. So I'm going to draw equal vectors. Vectors are equal when they have the same direction, magnitude, and are parallel. So the equal vector of F1, I'm putting that on the head of F2. So when I measure the same magnitude from here to here, and this is angle theta, when I extend the horizontal line, this angle must also be the same as this. So if this theta, this must also be theta. Then I can say that F1 is equal to this line, and so I also label it as F1. Then let me draw the same thing for F2. Put F2 on the head of F1. The same concepts. Vectors are equal when they have the same magnitude, direction, and are parallel. So, same magnitude as this, same direction. Okay, the angle between, when I extend this line a bit, the angle between this and this must be the same as this. Now, after realigning their direction, whether you look at it below, this follows this correctly. Now you can tell where they are going. This also follows this. So the resultant will be drawing a vector from the tail of F2 to the head of F1. That will be the resultant. So this direction becomes the direction of the resultant out. So when you look at it below, then you can say that, oh, okay, by their path, F2 plus F1 is equal to the resultant R. Or when you look at it up here, F1 plus, this is also F2. F2 is equal to R. So you have resolved the two forces as a parallelogram. And by this, they obey the triangle law of vectors. By this, the parallelogram obeys the triangle law of vector addition. All right. Now, we want to determine the resultant using Pythagoras theorem. So what we will do is that we'll draw a perpendicular line to this force. This line is perpendicular to the force F2. Now, if this angle is theta, what will be this angle? If this angle is theta, what will be this angle?
180 minus theta.
180 minus theta. We will call this as alpha. So we know alpha to be equal to 180 minus theta, meaning that if you know what is here, you can easily, what is here would be equal to what is here, and you can find alpha. If this is 120, because we are talking of obtuse angle, if this is 120 degrees, this will also be 120, and this will be 60. Please, are we fine?
Sir, please come again.
So, because this is parallel to this, parallel lines have the same slope or gradient. If this is 120, this will also be 120. And so if there's 120, then you can deduce that alpha will be 60. All right. So let's label this O, A, B, C, D. Now look at, we have two triangles here. This is also perpendicular to this. If this is perpendicular, this is also perpendicular. When you consider triangle BCD, BCD is a right angle triangle. What is this? This is, the hypotenuse is F1. This side, we don't know. The angle in there is alpha. This length, which is CD, we don't know. Because the whole length OC is equal to F2. But this length DC, we don't know. We want to determine, because this is perpendicular to this, we want to determine the vertical component and then the horizontal component of this. Now in trigonometry, whenever you are looking for vertical component, the trig ratio to use is sine. Whenever you are looking for horizontal component, the trig ratio to use is cosine. That is when you know you have the hypotenuse. Please, are you with me? Class, are you with me?
Please come again. Please come again.
In trigonometry, if you know the hypotenuse, which is the longest side of the right angle triangle, if that is known and you are looking for the opposites, if it's known, the hypotenuse is known, and you are looking for the opposites, the appropriate trig ratio to use is sine of the angle. If you are looking for the adjacent, please, this is known as the opposite or vertical. The appropriate trig ratio to use is sine of the angle. If you are looking for the adjacent to the angle, or horizontal, the appropriate trig ratio to use is cosine, cos. So I'm interested in, this is B, this point is B. The opposite is BD. The adjacent is DC. I want to determine BD. I want to also determine DC when I have the hypotenuse F1. Okay, so if I take the sine of the angle, the angle is alpha. This is opposite, which is BD over the hypotenuse F1. In fact, sine is, so the S indicates sine, O indicates opposite or vertical, and H is the hypotenuse. So therefore BD is equal to F1 sine alpha. So this component, the vertical component or the opposite, is F1 sine alpha. Since, and it will also point up. What I'm left to determine is DC. DC. DC is the adjacent. I need to use cosine, cos. So if I take cos of the angle alpha, I have cos is adjacent DC over the hypotenuse, which is F1. Therefore, DC is equal to F1 cos alpha. So it means that this side of the right angle triangle is what I've determined. F1 cos alpha. Okay. So concerning this side of triangle BCD, I found the vertical, I found the horizontal. Please, any question? Can I continue? All right. Now, I want to apply what I've done to triangle OBD. Please, I'm just developing a relation for you. Don't be trembled with all this. But I want us to confirm something. Consider triangle, the right angle triangle OBD again. That's another right angle triangle. OBD. So considering triangle OBD. Are you there? Class, are you there?
Yes.
Yes.
For triangle OBD, I want to apply Pythagoras theorem to it. So apply Pythagoras theorem to the right angle triangle, to the triangle. And here, Pythagoras theorem says that the square of the hypotenuse OB. So if I square OB, it must be equal to the sum of the squares of the other two sides. OD squared plus BD squared. BD squared. Okay, now OB is the resultant of the two forces F1 and F2. So R squared OD is this. But open your eyes and listen on. We have OC. OC is the whole vector F2. OD we don't know, but we have found DC. DC, we got it as F1 cos alpha. So class, if I have OC and have DC, how do I determine OD? Yes, anybody to help me? I have OC, which is F2. Then I have DC, which is F1 cos theta. How do I determine OD?
So
Yes.
please, I guess you subtract DC from OC.
Exactly. I must subtract DC from OC to get OD. So OD will be equal to OC is F2. F2 minus DC, which is F1 cos theta. Cos alpha, rather, the squared plus plus BD. BD, that is what I found. F1 sine alpha. BD. Okay, is the same as the opposite side of this triangle. So F1 sine alpha. So this squared. Good. Now, let's expand because the expansion is all that we need to prove our point. So R squared is equal to, we need to square this F2 squared. Then you need to square minus F1 cos alpha squared. And this will give us plus F1 squared cos squared alpha. Then F2 times F1 cos alpha negative F2 times negative F1 cos alpha. Whatever you get, you multiply by 2. And that will be minus 2F1 F2 cos alpha plus, you square this. When you square this, you have F1 squared sine squared alpha. That will be the expansion. Don't be trembled. We are proving something which you will use later. Okay. I'm just taking you through how some formula or relations were obtained. So we have R squared. Now group like terms. This is F2 squared. Okay. Then we have plus F1 squared. Let's bring this one first. Sine squared alpha plus another F1 squared cos squared alpha minus, this is what is left, 2F1 F2 cos alpha. In F1, you can factorize out F1. So F1 R squared is equal to F2 squared. When you pull out F1 squared, you have sine squared alpha plus cos squared alpha minus 2F1. Don't panic. This is not for you. The proving is not for you. It's for me. 2F1 F2 cos alpha. Now in math, sine squared alpha or theta, any angle, if you square sine plus the square of cosine is always equal to 1. So sine squared alpha plus cos squared alpha, the result is equal to 1. So you have R squared giving you F2 squared plus F1 squared, God, this is 1, minus 2F1 F2 cos alpha. This is the cosine rule. This is the cosine rule. Don't forget, I earlier also said that alpha is equal to 180 minus theta. Alpha is equal to 180 minus theta. So if alpha is equal to this, then when we substitute this in place of alpha, we can also get R squared is equal to F1 squared plus F2 squared minus 2F1 F2 cos 180 minus theta. Cos 180 minus theta is equal to negative cos. And so this whole relation can reduce to f1 squared plus f2 squared minus 2f1 f2 cos 180 minus theta is equal to negative of cos theta. So minus cos theta. So that negative times negative would multiply, and this whole thing will change to positive cos theta. So we could still get the cosine rule from here if the relation, the angle between them is obtuse. Example, let's solve a question. Okay, let's solve a question because you are tired of. Okay, before we look, let's look at the direction. This is the resultant, R. The resultant is going out. So if we are looking for the direction, it is this small angle between OD and then this. So let's assume this angle is beta. When we manage to get the direction of beta, we have the direction of the resultant. So once I know BD and OD, I can use tangents. So when I take tan of beta, tan beta will be equal to opposite, tangent is twa, opposite BD over adjacent OD. Now what is the opposite? BD gave us F1 sine theta. So F1 sine alpha all divided by OD. OD is when we subtracted. Okay, when we subtracted DC from OC. So this is F2 minus F1 cos alpha. So this is how we determine the direction of the resultant. Please, let's apply whatever we've learned to solve a problem. Okay. Hello, is that okay? Hey, Caleb. Caleb, your hand is up.
Can you come again with what you just said? My network just got cut off again.
We are looking at how to determine the direction of the resultant. You see, R points up. So when we are able to get the angle it makes with OD, we have the direction. Okay. So once we have the opposites to this right angle triangle, out of which we got R. Okay. So take the tangent of this angle. Tangent is opposite BD over adjacent OD. BD is F1 sine alpha, and then OD. Oh, don't forget we subtracted DC from OC to get OD. So OD becomes F2, which is OC, minus F1 cos alpha, which is DC. So when we take the tan inverse of this, of F1 sine alpha over F2 minus F1 cos alpha, we have the direction. So let's solve. This is how to determine the direction of the resultant. Let's solve a question, right?
Yes.
I know you are tired of the rigorous calculation. Let's solve a question. Two vectors of magnitude 30 and 40. I'm using 30 Newton and 40 Newton. Have an angle of 150 degrees between them.
Please, can you repeat what you said?
Two vectors of magnitude 30 Newton and 40 Newton. Have an angle of 150 degrees between them. Determine the resultants and then the direction of the resultant force. So we have to find the resultant, the result when these two forces of such magnitude interact. And when we finish, we are also to determine the direction of the resultant. So I think we can see better when we draw. So let's draw. So we have two forces. Paulette, are you there? Okay. Angel. Angel.
Yes, sir. I'm here.
Sappho. Roll call. Serious roll call.
Yes, please.
Okay. So F2 is 40. The angle between them is 150. If I give this example to you, I would expect you to first resolve it into a parallelogram. If you don't do that, I'll mark you down. So first, resolve the forces into parallelogram of forces. So resolve the forces into a parallelogram of forces, meaning you are expected to realign their directions. So I create an equal vector of F2 on F1. Equal vectors. So once this has the same magnitude as this, I can also call this as F2. Then create F2, F1 on F2. The same equal vector approach. Same magnitude and direction. So this is also 30 Newton. Now look at whether up or down. The direction now follow a sense of order. So the resultant is drawing a vector from the tail of F1 to the head of F2. So this is 150. Theta is 150, we know. So I don't need to even write. But when you extend this, because this line F2 is parallel to this, then this angle must also be 150. If this is 150, what will be this angle?
30 degrees.
30. If you want to directly use the formula, then the resultant, which will point up, would be equal to R squared, would be equal to F1 squared plus F2 squared. Two things, either minus 2F1, F2, cos of 180 minus 30. Because if you recall, alpha, we got alpha to be equal to 180 minus theta. So once theta is 150, then this will also be 180 minus 30, which will be 150. 180 minus 180 minus 150, which is 30. Or yes, a refer. I'm listening. A refer, I'm listening.
Mr. Please, I wanted to ask you if you could come again.
Feel
Please,
free.
I wanted to ask if you could come again on why we are adding the
Why
minus 2 F1, F2 costed.
you see, I gave you two different relations. If you look at it, in one of them, we had F1 squared plus F2 squared minus 2F1 F2 cos alpha. But this alpha, we saw that alpha is 180 minus theta. Please, do you recall this formula?
Yes, please.
Good. So I'm only substituting
Yes, please.
180 minus theta for alpha. But over here, we know theta. They gave us the angle between the vectors to be 150. So if this is 150, then this will also be 150, and alpha will be 30. This alpha, originally, we should have been cos of alpha. Because we know alpha, we are representing alpha by the value 30 degrees. Or you can also put in cos 180 minus 150, which will still be cos 30. Are you okay?
Yes, please.
All
Yes,
right.
please. Thank you.
So all that I'm saying is that this is cos of alpha, which is 30. The other formula we obtain, because cos 180 minus theta, I said is equal to negative of cos theta. The formula can also be r squared is equal to f1 squared plus f2 squared minus 2f1 f2, but cos 180 minus theta is also equal to negative cos theta. So negative times negative would give you f1 squared plus f2 squared plus negative times negative 2f1 f2 cos theta. So either we use cos 180 minus theta or cos whether this one or this one.
Please, how is cos 180 minus theta equal to minus cos theta?
Matse, let me prove for you. Yes, Caleb. Okay, let's prove why.
The board.
Pardon? Caleb, I'm coming. Let me quickly answer this question. I'm coming, Caleb. So whoever asked this, I said this is equal to negative cos theta. The point is that we have a double angle. If you have two different angles and you take the cosine of it, B. So the angles are A and B. Okay. And it can be plus or minus. But because what we have here is a minus, the reason for which I'm leaving, ignoring the plus and maintaining the minus. If you have this, the expansion of this is equal to cos A times cos B. Now, for cosine, if what is here is minus, it changes to be plus. It's a rule or it's a formula. So cos A times cos B plus sine A times sine B. That's the formula for expansion of cosine for double angle. So I'm going to use this formula to expand this. I have cos 180 minus theta. Now, when I apply this to this one, then I'll have cos 180 times cos, the other angle is theta. Theta, this is minus, so the operator that will be plus. Plus sine 180 times sine theta. Now, if you have your calculator, point cos 180 is equal to -1. Point cos 180. So minus 1 times cos theta plus then point sine 180. Sine 180 is 0. Please confirm. So we have plus
Yes, please, it's 0.
0 times any number is 0. So you don't even worry yourself. So this is 0 times sine theta, which is 0. But we have -1 times cos theta, which is minus cos theta. Plus 0 is the same as this. So this is how come cos 180 minus theta is equal to negative cos theta. Whoever asked the question. Are you okay?
Yes, please. Thank you.
Okay, please, is there any other question or I can move on? All right, so I have two formulas to use. Either r squared equal to f1 squared plus f2 squared minus 2f1 f2 cos 180 minus theta, or r squared is equal to f1 squared plus f2 squared plus 2f1 f2 cos theta. And here I get this because I am substituting cos 180 minus theta to be negative cos theta. And so negative, positive. If you use any of this, you need to get the same answer. So what is f1? F1 is 30. So r squared is equal to 30 squared plus f2. F2 is 40. 40 squared minus 2 times 30 times 40 cos 180. Theta is 150 minus 150. This is 900 plus 1600 minus 2 times 30. I wouldn't multiply it. But cos 30 degrees. Cos 30 degrees is equal to root of 3 over 2. Confirm. Cos 30 degrees is equal to root 3 over 2. Correct? Is that
Yes,
correct?
please. Yes, please.
Okay.
Yes,
So
please.
this and this would cancel. So I have 900 plus this 2,500 minus, please, this is 1200 times root 3. Multiply 12,200 by root 3 for me.
Sweet.
Come again. Thousand 200 times root 3.
2000 and
Is that 3,000 or 2,000?
2000.
2,000.
2000.
Mhm.
And
Oh, yeah.
78.
70.
2078.
Oh, your line is fading on.
2,078.46.
So subtract 2078.46 from 2,500. Yes, what's the answer?
400.
401.539.
Okay. 421 points. Okay.
539.
5. Okay. Then the square root of this. Take the square root of 421.54.
20.531.
So 20.531 Newton is the resultant force. So it means that if we are going by this is what we'll get as the resultant force. Let's go by the second formula, which is plus this. So if we use the second formula, we have r squared equal to 30 squared plus 40 squared plus 2 times 30 times 40 cos of 150, because theta is 150. So 900 plus 1600 plus 2 by 30 by 40 cos 150 is the same as negative of cos 30. So this is minus root 3 on 2. Let's confirm. Point cos 150 and it's equal to negative of this. Correct?
Yes.
Yes, please.
Okay, so this and this will cancel, but we'll have positive negative. So minus 1200 root of 3. It brings us back to the same thing, confirming that yes, both situations would give you the same results. So R will be equal to square root of 421 point, which is 20.531 Newton. That's it. Then the direction of the resultant. Yes, here, if we use cosine rule or what I gave you, the value is the same. Please, can I clean this side? The first part of the solution.
No, please.
Yes, please.
Okay, then if you are writing, please hurry up. So both ways must give you the same results. Okay. Can we continue? Hello, can we continue?
Yes, please.
Okay, so if we are to use cosine rule, the cosine rule is the ratio of sine of, did I say cosine rule? Sine rule is a ratio of the sine of angles within the triangle. So we have this angle 150, 150, this 30. And we are looking for, this is the direction of the resultant. So we are looking for this angle, which certainly will it be greater or less than 180? 150. Will the angle be greater or less than 150? By your visual judgment. Hey, nobody is feeding my
Less
back.
than.
It
Sir,
will be
please,
less
can you
than.
repeat what you said again?
This alpha is the direction of the resultant. My question is, will it be greater or less than 180? Well, 150, sorry. Because the 150 is at the angle between the forces.
Less.
It must be less. So, if you are to use the sine rule, the sine of the angle in question, alpha. Here we are saying let the direction be alpha over the side opposite to the angle. This is the angle, the side opposite to it is F2. Must be equal to the sine of any other available angle. 30 is available. So sine of 30 divided by the side opposite to this angle 30, and that is the resultant. R is directly opposite to 30, the angle 30. So over R. So we are interested in sine alpha. Let's make that as the subject. So we'll have sine alpha being equal to F2 times sine 30 on R. What is F2? 40. So 40 times sine 30 over R. We got 20.53 for R. So we saw sine 30 is equal to half. So 0.5 over. So we have 20 divided by 20.53. 20 divided by 20.53. Please compute that for me. This must be 0.20 divided by 20.53.
0.974.
0.974.
74.
Okay. Therefore, alpha, which will be equal to the sine inverse of this, must be an angle which is close to 90. Because sine 1 is 90. But this is 0 close to 1. So it must be an answer close to 90. Please press on shift sign
76.906.
76.9. Please check well for me.
76.906.
Okay. So approximately 77. Is your calculator at D, R, or G? Check for me. Is it on D?
Yes, please.
Please, I got
Okay.
the same answer. And mine is on.
Okay. Because if it's not on D, and it's on R or G, it will affect your answer. Okay, so this is the direction of the resultant, meaning the resultant is as at an angle of 76 degrees from the 30 Newton force. 76 degrees from the 30 Newton force. That is what it means. Okay, let's Gabriel.
Sir, please, apart from sine alpha, is there any other rule you can use to find the
The
direction?
direction. And that's what we are coming to look at the other way out. Don't forget, I gave you another relation, and that is when we resolved it into F1 sine alpha, okay, and this side as F1 minus, sorry, it's F2 rather, F2 sine alpha, and then we determine OD, and that F1 minus F2 cos alpha. Then we determine this angle by considering tan alpha is equal to the opposite, which is F2 sine alpha divided, let me change this to beta because of what I represented this angle by, divided by OD, which was F1 minus F2 cos alpha. You recall, I also use this to determine the direction. So let's see. What is F2? 40? Sine of alpha is 30. Divided by F1 is 30 minus F2 cos alpha. So 40 times cos of 30. So the numerator we have 20 because sine 30 is half. 20 over cos 30 is root 3 on 2. So 20 root 3. Please, what is 20 times root 3? What I'm saying is 40 times cos 30 must be equal to 20 root of 3. So give me 20 root 3 in decimal. What is 20 times root 3? Oh, anybody?
34.64.
30.
4.64.
24.
Okay. So I'm coming. This is F2. F1 is this. Okay, so F1 is 30. So when we subtract this, okay, 40 cos 30 from, okay. Meaning with this, based on my values, this will give us a negative angle, which will not work. Because 40 cos 30 is greater than 30, it will give us a negative. So per the question I crafted, this is a question I just picked from mind. Okay. So this tangent one will not work for the values I picked. Okay. It would have worked for the values. Yes, this will not work. So the only approach will be the sign rule, because the denominator will be a negative, which is not meaningful. Okay, so per the values I created, it will go for the sine rule instead. All right. So, in fact, going forward, I'll look for other examples where both would apply, then we solve it. Okay. Now, one other thing I want you to understand is that I think, let me check the number of minutes we have. Okay, less than 30. Can I clean the board? Can I clean the board? Yes, you are not answering, but yes. The cosine rule. It means that the cosine rule is a super rule for determining the resultant for two forces, two vectors in any direction. But the point is that the sine rule, the cosine rule are limited to only two forces. You can't apply it to more than two forces. You can only do so for when you have two forces acting against each other in a certain manner. So that is a super rule. Don't forget, when we're looking at two vector quantities or forces acting in the same direction, we saw that when two vector quantities are acting in the same direction, the resultant is equal to F1 plus F2. And here the angle between the forces is equal to what? The angle between the forces when they are moving in the same direction or parallel is equal to what? Oh, hello. Are you there? No, when they are moving in the same direction, the angle between them, the two forces is equal to
180.
no.
0 degrees.
It's 0. Please, let's not waste time with our responses, please. So 0. Then, when they are moving oppositely, so same direction. When they are moving oppositely, R is equal to F2 minus F1, depending on which one is great. And here, theta is equal to what? Theta is equal to
180.
180 degrees. When they are moving perpendicularly, so same direction, opposite, perpendicularly to one another, R is equal to the square root of F2 squared plus F1 squared. And here theta is equal to
90 degrees.
90 degrees. Now, at any other angle, at any other angle theta, the cosine rule must apply to all of them. And this is the cosine rule. Okay, this is the cosine rule. Either minus 2F1 F2 cos of 180 minus theta, or R squared is equal to F1 squared plus F2 squared plus 2F1 F2 cos theta. Now, the cosine rule applies to all other angles, whether they are in the two forces in the same direction or in opposite direction. Let's apply this, the cosine rule, to test same direction on opposite direction. For same directions, so for same directions of forces, two, please limited to two forces. We said theta is 0. If you pick any of the two formula, whether the first one or the second one, I'm picking the second one. And then you put in the value of theta, 0. This is what you have to get. What is cos 0? What is cos 0?
1.
It's 1. So if cos 0 is equal to 1, then you have 1 times 2f1 f2. Please, class, what is f1 squared plus f2 squared plus 2f1 f2? What is this? Yes, Gabriel. Your hand is up. Gabriel, what is f1 squared plus f2 squared plus 2f1 f2? What's that?
Cosine rule.
No, I mean, what is f1 squared plus this thing that I've put into the rectangular box? What is it? Do you have any idea? If the idea is not coming, then expand this for me. f1 plus f2 all squared. Expand f1 plus f2 all squared. Yes, Gabriel.
Please, you get f1 squared plus f2 squared plus 2f1 f2.
So it means that this is the same as what I've put inside the rectangular block. Correct? This is equal to this. So I can say that r squared is equal to f1 plus f2 all squared. If you want to find r, what do you do? To find r, what do you do?
Square root both sides.
So you take the square root of both sides of the equation. And you have r being equal to f1 plus f2. So it is bringing us back to this same thing. What we learned for two bodies moving in the same direction. So we are obtaining the resultant of this from the cosine rule. The reason for which I said the cosine rule is a powerful expression which applies to all of them. Now let's do it for when theta is 180. When theta is equal to 180 degrees, let's put that into the cosine rule. So when theta is 180, we have r squared is equal to f1 squared plus f2 squared plus 2f1 f2 cos 180. What is cos 180?
-1.
Good. So we have minus, this is negative, so minus 2f1, f2. What is this? What is this thing in a rectangular block? What is it?
F1
Yes.
minus F2 all squared.
Good. So r squared is equal to f1 minus f2 all squared. So that when we take the square root, we have r is equal to f1 minus f2. So out of the cosine rule, we are obtaining this formula when two bodies are acting oppositely to one another. Of course, this indicates that f1 is greater than f2. If theta is 90, put theta into the cosine rule formula and help me get the resultant from this. So put theta into the cosine rule formula, which is this one, and help me determine the resultant. If theta is 90, I'm waiting for you. I'm waiting for everyone. What have we had? Hello, what have we had for that? A revoir. Easy, Colette.
Sir, please. Sir. Sir, please, I
Yes.
had r is equal to all square roots f1 square plus f2 square.
So, in effect, all that we are saying is that the cosine rule can be applied to all directions. Please, is that okay? Is that okay? So it overrides all of them. All right. So, but the cosine rule, the sine rule is limited to only two forces. Meaning, if you have three vector quantities acting at a point, you can't apply the cosine rule and the sine rule to it. But there is another way out to do the same thing. So on Friday, we'll look at when you have more than two, how do you determine the resultant and then the direction? Is that clear? So this is where, if you have any question, ask. If you don't have any question, then we end our session here. Any question? All right. So we'll continue on Friday, but as usual, I'll look for questions which would challenge your thoughts and then drop it inside the group for you to try your hands on. Until the same time Friday. If I take care of yourselves, and bye-bye to all of you.
Bye. Bye. Bye.